One of the reasons it's important to know the nomenclature of anions, particularly polyatomic anions, is it helps with acid nomenclature. Remember, acids are a certain type of chemical that always begin with the letter H. So let's look at some acids and how we can figure out how to name them based on the anion. If the anion name in the acid ends in "ide," and in an acid the H is always going to have a positive charge, so whatever's after the H is going to be your anion. So this would be chloride, would be the name of this anion here. So we would name it by adding the prefix hydro and end in ic. So HCl, the chloride anion, is hydrochloric acid. HBr, the bromide anion, hydrobromic acid. And HI, the iodide ion, is hydroiodic acid. Now, let's look at our oxyanions, these polyatomic ions that have oxygen in them. If the anion name in the acid ends in "ite," change the "ite" to "us" acid. And the way I remember this is I, us, because there are two pronouns, I and us. So "ite," us. So here's HClO. Here is our H. We look at the anion. This is hypochlorite. So the name would be hypochlorous acid. We change our "ite" to "us." Here's our acid. We take away the H. We're left with chlorite. So chlorite goes to chlorous acid. If the anion ends in "ate," those are the two possibilities, ide, ite, or ate, then the ate changes to ic acid. And I remember this by saying I ate something icky. So we take away the H, we look at the anions that left. ClO3 is chlorate, so this turns to chloric acid as an acid. ClO4, that is perchlorate, so this goes to perchloric acid. So that's how you can name acids. Now let's look at naming binary covalent compounds. And I wanted to put this covalent in here because that's key. We are looking at covalent compounds that are made only of non-metals. So this is different than ionic compounds. There's only non-metals. The less electronegative atom is usually listed first. We haven't gone over electronegativity, so I'm kind of going to have to ignore this first rule here. And then a prefix is used to tell us the number of atoms in a molecule. And here are these prefixes. They're based on the Greek language, and the only caveat is mono is not used for the first element. So let's look at these two binary covalent compounds. We know that they're covalent because each one of them has non-metals. Carbon, oxygen, and chlorine are all on the right-hand side of the periodic table, which makes them non-metals. So these are not ionic compounds. They are not being held together by negative charges. Two non-metals would both have negative charges, and two negative charges would not be able to stay together. It is the attraction of opposite charges that allows ionic compounds to stay together. So when we identify our compound, let's see if I can get a space here. We identify our compound as binary covalent, binary meaning it's made up of two different elements, and covalent, let me put that back in there. And covalent, it's nonmetals only. Then we name the first element with its elemental name, and then the second element ends in "ide." And then we have to tell how many of each atom is in a molecule by using these prefixes, but we don't use mono for the first. So here we have one carbon, but since it's one of the first, we don't use mono. And then we have two oxygens. The first element retains its name, carbon. The second ends in "ide," dioxide. This right here, carbon is first. Chloride, the chlorine is second, so it goes to chloride. So carbon tetrachloride. So let's look at this one here. This is a binary covalent compound. And we notice there's a 2 after the nitrogen, so this is going to be this is going to be dinitrogen pentoxide. Now notice it's not pentaoxide. If there's an A and an O together, we typically get rid of that A from our prefix and just let the O there. There's another type of compound known as organic compounds. They are made up of carbon and hydrogen primarily. They have their own system of naming, which is beyond the scope of this course, but just for your edification, the simplest organic compound is methane, the next is ethane, and the next is propane. This is a major component of natural gas, and propane we know is used as a source of heat, either in houses or in gas grills and things like that. So we've looked at naming 3 different types of compounds. First we have ionic, and that is going to be a metal typically, and a non-metal, something that's positively charged, something that's negatively charged. The only time you're not going to have a metal is if you have a compound with a polyatomic cation ammonium. This is the only cation that we're going to be looking at in an ionic compound that's not a metal. Then we look at acids, and we're going to use the anions to help us name acids. And then we have our covalent compounds, and these are non-metals only, and we use the Greek prefixes di, tri, tetra, etc. Now, be very, very careful not to confuse these 2 naming systems. We never ever use di or tri for ionic naming. Remember, we use the Roman numerals if we need to, and those Roman numerals do not let us know subscripts. The Roman numerals tell us the charge. So after a little bit of practice, I'm sure you'll be experts at this.